So today we're going to start doing our notes on chemistry. The first part of the notes should hopefully be a review of stuff that you've already learned in chemistry from past classes. So we'll go through it pretty quickly and just do some review and some drawing and make sure you understand what we're doing. So this is atomically correct, the chemistry of life. Remember that this is from chapter 1 of your textbook. Okay? All right. So just to kind of start off, when we talk about, like, sometimes you'll hear people say, like, what's the matter? And well, what we're talking about with matter in science is a little bit different than if somebody says to you, what's the matter? Like, what's wrong with you? Matter in science are all of the materials around you. They're all made up of matter. Matter is anything that has mass and volume. And mass is the amount of stuff in a material. So mass is the amount of stuff in a material, and volume is the amount of space that that stuff takes up. So what I would like you to do real quickly on your sheet in front of you is to jot down an example of solid, liquid, and gaseous matter. So look around you, wherever you are taking these notes right now, and write down some examples of those things. The next thing is to answer the question, is all matter visible? Can you see all the matter? And does all matter take up space? Okay, so answer those questions now as you think about anything that has mass and volume. Okay, so when we talk about matters, we're talking about atoms, and atoms are the smallest particle of matter that still retains those same properties. So the smallest particles of matter. Okay, so the smallest particle of matter or of an element, when we're talking about the periodic table, that still has the properties of that element. So if we're talking about gold, it's the very, very smallest piece of gold that you can still have with it still being gold, or silver, or oxygen, or hydrogen, or any of the atoms on the periodic table, or the elements. There's 3 subatomic particles in an atom, and those are the proton, which has a positive charge and has a mass of 1 AMU, atomic mass unit. AMU stands for atomic mass unit. So it's a positive charge, it has a mass of 1 atomic mass unit. Neutron is the next one. Neutron has a neutral charge and its mass is 1 AMU. An electron has a negative charge, and its mass is like 1/2000th of a proton. So we really don't consider the mass of an electron at all. We usually say that it's 0. Okay, the structure of the atom. So atom is made up of the nucleus, which has the protons and the neutrons. Remember, neutrons are positive, protons are positive, neutrons are neutral, and those are located in the nucleus, which is in the very center of the atom. Surrounding the center of the atom are electron shells. And in those electron shells, the first shell can hold 2 electrons. The second shell can hold 8 electrons. And the third shell can also hold 8 electrons. It actually holds 18. But with our purposes in biology, we really only look at the first 3 rows. And anytime that an atom has 8 electrons, it is stable, which is called the octet rule. So we're just going to use 8 for our purposes. But remember that it actually can hold 18. Okay, so just a couple other background pieces of information. We have elements, which are substances that are made up of only one type of atom. So the example that we gave before, like gold or silver or oxygen or hydrogen, all have many, many, many atoms in them, especially when you can see them, because atoms are so teeny tiny. They have millions of atoms in them, but the only type of atom they have in it is that type. So gold only has gold atoms. And the difference is their atomic number. The atomic number is the number of protons in the atom. So each element is different based on the number of protons that it has. It also gives a number of electrons. Why do you think that could be? Think about that for a second. So what's the charge of a proton? Positive. What's the charge of an electron? Negative. An atom has to have a neutral charge, so you have to have the same number of protons as electrons. So that's why it gives you the number of electrons. And then you have atomic mass. And atomic mass is the number of protons plus the number of neutrons. So to figure out your number of neutrons, you take the atomic mass minus the atomic number, and that gives you the number of neutrons. Another thing that we have are isotopes. And if you look at the atomic mass on the periodic table that you have in front of you, you should notice that it is in a decimal. And that decimal is because it's an actual calculation of the different isotopes that are found in nature. So isotopes are atoms of the same element. So that means that they have the same number of protons, but they have a different number of neutrons. Since neutrons have a neutral charge, they don't change the identity of the atom. So they have the same number of protons, but they have a different number of neutrons. And they are important in science for a couple of different reasons. One, remember when we talked about evolution and we said one of the pieces of evidence is determining the age of fossils. Well, they use isotopes in order to do that. Radioactive isotopes break down. They also use it in a lot of medical testing. Like some people, if they have something wrong with their intestinal tract, will have to drink a fluorescent dye, and that dye helps to illuminate if there's any problems. The same thing is true when they do injections to see if you have any blockages in your heart. That's one of the ways that they can do it. So it's used both medically and identifying fossils and things like that. Okay, I'm going to switch what we're looking at real quick to this. Sorry. All right, so this is a molecule of an atom. When we draw our atom, we start off with a single, so please draw this in your notes right now. You start off with a center circle, and in that center circle is where we're going to put the nucleus. And the nucleus, like we said before, is made up of protons and neutrons. So that goes in the very center. Then you draw another circle, depending on how many electrons there are. You draw another circle that has 2 electrons. Then a third circle that has 8, and then your last circle that has 8. Remember that 2 is how many the first one can hold, then 8, and then 8. So draw this atom in your notes so that you know what the basic structure of an atom looks like. Okay, so then the next thing we're going to do is draw an atom of carbon. And there's a couple steps to drawing an atom. The first step is to determine the number of protons, neutrons, and electrons in the atom. And then we draw the atom. And then we determine if it's stable or not stable, and then we determine what needs to do to become stable. So this is an example of the atom off of a periodic table. So the first step, again, is to determine the number of protons, neutrons, and electrons. So the protons, remember we said, is equal to the atomic number. So look on your periodic table, and what's the atomic number of carbon? You can see it's identified right here, and that's 6. So that would give you 6. Electrons are the same as protons, right? Let's make sure we put our symbols in here. So how many electrons would carbon have if it's the same? Right, 6. And then to get neutrons, these are all superscripted, so make sure you do that on yours. Let me do that real quick. I'll just take a second. So proton is a P with a little plus sign showing that it has a positive charge. E isn't for electron, has a negative sign, and then the 0 for neutron because it's neutral. Okay, so to figure this out, it's the atomic mass minus the atomic number. So for carbon, it's 12, and it's 12.01, so we just round to the nearest whole number, and so we'll just leave that at 6. So, or at 12, I'm sorry, so 12 minus 6, which is the atomic number, equals 6. So in this case, we have the same number of protons, neutrons, and electrons. That's not always the case. Protons and electrons are always going to be the same, but sometimes neutrons is going to be different. So our next step then is to draw it. So I'm going to go ahead and put in my circle, my first circle. And remember that is my nucleus, and inside the nucleus goes my protons. Let me move this over a little bit. So my 6 protons and my 6 neutrons. And then the next thing are my electrons. And like we said before, the first shell of electrons can hold 2 electrons. So I will put 1 electron here, and then I'll put another one over here. So they're usually found on opposite sides of the atom. All right, so do I have is that all my electrons I have? If you take a look, you have 6 electrons here, and we have already used 2, so we have 4 left, so 6 minus 2. So I need to go on to my second electron shell, and how many can that hold? Right, and it can hold 8, and then I only have 4 though. So I put my 4 electrons here around the outside. So 1, 2, 3, 4. Okay, so now I have my 6 electrons, my 6 protons and my 6 neutrons here inside the nucleus, my 2 electrons on the first shell, and then my 4 electrons on the second shell. Okay, so is it stable or not stable? In order to determine that, you have to look at this outer shell. This outer shell can hold 8 electrons. In order for it to be stable, it has to have that number of electrons. So it is unstable because it only has 4 electrons. It only has 4 electrons in the outer shell. And then to become stable, it either needs to gain or lose 4 electrons in order to get it to 8. Now you're going to choose whatever it is. So if there were 6 electrons here, it would be easier to gain 2 than it would be to lose 6. So you're going to put that you would gain 2 electrons. Okay? All right, I want you to go ahead and practice one. So go ahead and do oxygen. Draw that in your notes, then I'll take a look at that tomorrow. And then I want you to fill in this chart as well. So use your periodic table, look up the atomic mass. Remember, you can round that to the nearest whole number, the atomic number, the number of protons, the number of electrons, the number of neutrons. Okay, so calculate those and draw your atom of oxygen and have that ready to go for tomorrow. Okay, if you have any questions, please take a moment to write those down at the bottom of your paper, and then we'll be sure to go over that first thing tomorrow. Thank you. I'll see you tomorrow. Have a good day.